Hello, good morning, good afternoon. Welcome to today's session. My name is Willie Jackson. I work with Afribot Robotics. In our last video, we learned about uh, turning, the different turning techniques. We learned about sensors, and in this case, we learned about infrared sensor, IR. Um, we did a custom build. We just using one sensor. And today I'd like us to dive deeper to program our robot to follow a line. So we use the blank space to learn introduction. We use the coordinate ruler to learn the turning techniques. And today we'll be using the ellipse to line following. Yeah? So you will head straight to robot building, and you'll pick on. If you already have a built robot with at least 3 sensors on board, well and good. If not, you can customize one quickly. You just head straight and customize one. So for me, I'll delete these 2 sensors. Okay, so if I delete this, what will be the effect? Okay, all right. I'll delete the 2, and then I'll test if my robot is able to move properly. Motor 1, motor 2. Then maybe I give it encoding value of 2 there. Okay, let me see. Yeah, so my robot is able to move. So what I'll do next, I'll get back to the building and make sure I've labeled my sensors correctly. So this should be P1. So I'll have this as P1. This should be P2, my sensor 2 on port 2, and this should be on P3. Okay, so these are ports. I'm just assigning the photoelectric sensors to the ports. Okay, so I've assigned the first one on my left hand side to port 1, the second one to port 2, and the third one to port 3. Okay, so once that is done, I'll proceed and click on save. This case, I'll save it as build 3, 1 million STEM teachers, 1 million STEM teachers for Africa. Okay, so that is done. Okay, sorry. It's time to learn now some programming. So we'll be programming our robots to follow this line, okay? To follow this line. So as you can see here, our robot is on the line. Sorry, our robot is on the line, but then from the data panel, there is no sensor that is seeing the line, okay? So I'll adjust this robot to have the P2 on the line. So you can see now P2 is reading 1 on the digital value, reading 1 to mean it's seeing the black line. If I put it on the side this way, P3 is seeing the line now. P3, as you can see, P3 is on the line. P3 is on the line. If I put it this way, then our P1 is now on the line. Okay, remember our robot is this way, so P1, P2, P3. So P1 is now on the line. So I'll proceed and program this robot now. I want to program this robot, give it instructions that if P2, that is the center in the middle, is seeing the line, then it should move forward. Okay, if P1, sorry, yeah, that is P1. If P1 is on the line, then it should adjust to have P2 on the line. So how should it adjust? By turning. So which turning techniques are we going to use? Are we going to stop one motor and have the other motor move, or are we going to reverse one motor and have the other motor run forward? So we'll get to know that. So that is on P1, same to P3. So if P3 is on the line, then I'll need to make that adjustment as necessary. So let us proceed. Let us go to head straight to the code. So today we'll be working with most of these blocks and palettes. So I'll click on control to create the loop. So I want everything to be happening forever, like in a continuous loop. Then I want to have 3 conditions. Okay. So the first one, the second one, and the third one. Okay. So the first condition, I'll go to the sensor block, sensor palette, and have digital Boolean block. Where is it for the Boolean block for the photoelectric sensor? Let me see. Light sensor P1. This one. Get light sensor P1. Get light sensor P2. Get light sensor P3. Okay. So I have P1, P2, and then I have P3. All right. P1, P2, P3. Okay. So if P1 is seeing the line, P2 is not. So not seeing the line. So we'll go to operators and have it negated. So if this is not seeing the line and this is seeing the line, and then I'll need to join all this together. So I'll need to join all this together. So how do I do that? I'll need such an operation so that I have this here, I have this here, and I have this here. Okay. So I have P1 seeing the line, P2 not seeing the line, and then P3 seeing the line. Okay. So this case I need to move forward. So how do I move forward? We'll head straight to, we already learned how to move forward. So we can just do this. This will make that robot move forward. Set motor 1, set motor 2, and then let me duplicate this so I can edit it for the next condition. So the third condition is when this robot is here. Sorry, let me see. So that is it's on P1. So is P1 is seeing the line. Sorry. Okay, let me use debug mode so I can drag it. Okay, sorry. Okay. P1 is seeing the line. So if P1 is seeing the line, that is P1 is seeing the line, then I need this motor, the motor on the left hand side, sorry, the motor on the right hand side to move forward. I need this motor to move forward, and then this one to move reverse, like to just have a differential turn. Okay. This one to move forward, and then this one to move reverse. So let me check if this is motor 1, then the other one is motor, if the motor on my right is M1, so I click on the motor to just check the configuration. So let me see. So I normally prefer naming from this side. So this again is M1. Okay. And this is M2. Very good. So that is all right. So I'll go back. And now this time I'll put it there. I'll position my robot to see the black line. That is P1. So if this condition is true this way, then M1, the motor on the right hand side, sorry, M2 should move forward, M1 should move reverse to compensate. M2, let me just duplicate that condition. M2 should move forward, and then M1 should move reverse to compensate. Okay. And then the same for opposite condition for the next one. Opposite condition for the next. So this will be negative 50. This will be negative 50. So we'll have that. So we need to cross check that condition again. M1. Sorry. This should be here. Sorry. Apologies. So now for this condition, this is when which sensor is seeing the black line? So which sensor is seeing the black line here? P1 is seeing the black line. When P1, have a look at the data panel. Have a look at the data panel. P1 photoelectric sensor is seeing the line. So we are driving M2 forward, M2 forward, M1 reverse, M1 reverse, M2 forward, M1 reverse, M2 forward. So M1 reverse, M2 forward, M1 reverse, M2 forward. Sorry, let's start with that condition. M1 reverse, M2 forward, okay? So for this case, P1 is seeing the black line. P1 is seeing the black line, and then this is not seeing the black line, and then oh, P1 is seeing the black line, and then this is not seeing the black line, and again P2 is not seeing the black line. As you can see, P2 and P3, they are not seeing the black line for this condition. So we'll add a note, so P1, P2, P3, sorry, this is P3. So P1, P2, and P3 there, okay? P1, P2, P3, P1, P2, P3, P1, P2, P3, okay? So I'll have it there, P1, P2, P3. The other condition is when now P2 is seeing the line, but then P1 and P2, is when P3 is seeing the black line, P3 is seeing the black line, but then P1 and P2 are not seeing the black line, okay? So we have the note shift to the other side. So these are not seeing the black line, these are seeing the black lines, okay? All right. So the first condition is when the sensor in the middle. Okay. We made a mistake here. For forward, when the sensors at the end are not seeing the line, sorry for that. When the sensors at the end are not seeing the line, okay? So we add the note here, note, and then another note here, okay? Sorry for that. Another note here. So P1 is not seeing the line, P2 is seeing the line, and then P3 is not seeing the line. We move forward. P1 is seeing the line, P2 and P3 are not seeing the line. We adjust to the left. We adjust to the left, so we can have P2 on the line, okay? So if P2 is on the line, it will return to this condition, and then this condition will move it forward. For the third if condition, if P1 is not seeing the line, P2 is not seeing the line, and P3 is seeing the line, P1 not, P2 not, and then P3 is seeing the line, P3 is seeing the line, okay? So what do we do? P1 not, P2, and then P3 is seeing the line, P3 is seeing the line, P3 is seeing the line. Yes, we are all right. So we adjust, so we can have P2 back to its original orientation, where it's moving forward. So we have everything on a forever loop, everything on a forever loop, everything on a forever loop, everything on a forever loop. And that being the case, once we have that, okay, once we have that, then we could give it a try. We go to the simulation and see how it behaves. that was seamless. Yeah, so if you write a good code, everything will just work the way you want it to, okay? So you can see our code is very healthy. Our code is very healthy, precise, and you can see it's moving. It's following that line. Okay, following it perfectly, 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 perfectly. Okay, this is what I really expected. uh, Interesting. This is wonderful. This is wonderful. This is wonderful. Let me know in the comment section if you manage to achieve this. I know. Let me show you some mistakes some educators do make. Some mistakes some educators do make. So mistake number one is if mistake number one is if you have this as M1, okay. If you have M1 go 50, okay. If you have M1 go forward, and then M2 you have it reverse, okay. Like you have uh, this you have a very good argument here, but then on the instruction to the motor it's similar to that of when P3 is seeing the black line, okay. So if you have this, see what you're likely to have. Okay, it will run for some time. It will run for some time. To run for some time. To run for some time. Yes. See? You see? See what you'll have? You'll end up with this. Okay. It will run for some time, but then you'll end up with such. Mistake number two that I see most educators make. Mistake number two. Let me turn this to negative 50, and then this is 50. Mistake number two is having a similar condition. When you have a similar condition, so I'll keep this here. Okay, I'll keep this here. When you have clear instructions to your motors, but then you have a similar condition to that E you do. So you have this here, and then you have a note here. See what you'll have when you're simulating. For some time it will be all right, and then you'll end up with this and you'll be stressed. Okay, you'll be stressed. You'll be wondering what is wrong, but just that simple mistake. Okay, because see your robot is turning, and your robot is just turning instead of following that black line. Okay, that's another mistake I see most educators make. So I'll return this. I'll put it back. I'll put this back. You can see our robot is moving well. Our robot is moving well. Our robot is moving well, following the line. Following the line. And that's it. So just to explain again once more, for the first condition is to make this robot move forward, because for us to follow this line, we want to make the robot move forward. Okay. Now, when does it move forward? When P2, that is the sensor in the middle. Okay, the sensor in the middle. The sensor in the middle, P2, is seeing the black line. That's the only condition we are having our robot move forward. When the sensor P2 is seeing the black line. Okay, sensor P2 is seeing the black line. That's the only condition when we're moving forward. Okay, right. And for us to move forward, it's motor 1 forward, motor 2 forward. Okay. Again, I see you may have the same code like mine, but then your robot won't work. Okay. For example, if this robot is working perfectly, okay, but if I come here and interchange these motors, I have this as reverse, okay, reverse, and then yeah, I have just that one motor working in reverse mode, and these are the one working properly. These are the one working. This is motor, yeah. So if I have these motors working in reverse polarity, then I'll have another problem. You see? Okay. You see that? You see? So my robot is just okay. Okay. My robot is okay. My code is perfect. But then my motor is not working properly. My motor is in reverse. Though there are some conditions where maybe when you're working with some robots where you're not able to change the polarity of the motor on the screen, this can work. But I'll show you in another video on how you can go about it. It's important for you to know that forward is really forward. So if for that case, if our robot was working in reverse polarity, then once we are here, for this case, we'll add negative sign here. Okay. For this first condition, we'll have run motor 1 negative 50 and run motor 1 negative 50. Okay. So for this case, this robot will move forward. It will move forward for this case. You see? Sorry. Oh yeah, I have a condition here that is checking. Sorry for that. I have a condition here that is checking if that line is blah blah blah. But if I had, let me just show you something. Um, if I had, so I'll have this here, and then I duplicate. If I had just this, and I want to test forward motion, then this robot should be able to. Sorry for that. Let me confirm if everything is all right here. I swapped this. I had it. This was our M1 on reverse, and then this is our M2 on reverse. So M2 reverse, M1, M1 reverse. So that's on reverse. Yeah. So if I had this M1 reverse and M2 reverse, looks like M2 is not reversed. M2 is not reversed. M2 is not reversed. M2 motor M2 motor M2 motor M2 is working on reverse now. Let me see this. If I put it here, okay. Let me check this. Just a second. Again, these are just some of the mistakes I'm just trying to debug. I've created a problem and I'm trying to solve that problem myself. Let me do. Let me save that. Oh, okay. I didn't update on the configuration here. CDC 1 million teachers for Africa. Okay. You want to replace it? Yeah. No. Just want to control S. Let me see. Okay. M250. 250. Oh, okay. So one motor, when you have this case, oh, okay, for this case, our M1 is on reverse. So our M1 is on reverse, and you can see when I tell this robot M1 speed of -50, M1 speed of -50, it's moving forward, and M2 it's connected properly. So M1, for this case, M1 is on reverse, and M2 is working properly. So when I tell it M1 speed of -50, you'll see my robot is moving. M1, yes, M1. M2, very good. Yeah, so M1, -50, M2, so this should be now back to 50. It should be able to move Control S, back to 50, 50, and then it should be able to move forward before I return our main code. Let me just inspect this code and see. It's 100, 2. It boils down to robot design again. So I may have to just check if everything is alright here. Control S. Okay, this is M2, this is M2, okay, then this is M1, this is M1, this is M2. Okay, so you have to get that right. If you don't get it right, you'll have problems. If you don't get the configuration right, you'll have problems. So you can see my robot is now moving forward. So it's moving forward. Yeah. So it's really important for you to confirm which direction is your robot moving. But how you do that, you just need to confirm with a simple code. For this case, I'm expecting my robot to turn, to keep turning. Very good, very good. And then that is clockwise. Then for this case, I'm expecting my robot to, if I do 50 here, if I do 50 here, and then I do -50, I'm expecting it to turn anti-clockwise. Very nice. So I can comfortably return the code. Can comfortably return this code here. Okay. Can comfortably return that code. And you can see my robot is now moving, following the line. And our code is clean. Okay. So again, we need all right, I was checking that one. Yeah, so it's important for you to learn how to build a very simple line following robot. After building that line following robot, of course, factoring in a few sensors, so at least 3 for a beginner. Though those who intermediate teachers and above, advanced teachers, those who are used to robot programming, you can achieve the same with 2 sensors. And those who are really good can also achieve line following just with 1 sensor. That is line following or photoelectric sensor. Thank you so much. And if you are new here and you'd like to join 1 million teachers for Africa, feel free to reach us at afribot.africa. So send us a mail, info@afribot.africa, or call me at +254 7015 18100. Thank you so much, and see you in the next video. Bye.